Okay, hey there, Math 1070. We are now going to look at 4.3 notes, okay? So 4.3 talks about polynomial long division and then a process called synthetic division. And synthetic division is just a shortcut for polynomial long division. But before we look at division with polynomials, I want to just remind you of a couple of things with division with smaller numbers like you did back in elementary school. So if we were to divide the problem that I've written on the screen, 723 divided by 5. So the first step, if you remember, dividing by hand, like get rid of your calculator, is to simply divide. Okay, and so we would take 5 and divide into 7, and 5 divides into 7 one time. And then if you remember, the second step is to multiply. And so 1 times 5 is 5, so we bring a 5. And then if you remember correctly, the next step is to subtract. Okay, and 7 minus 5 is 2. And then the fourth step, of course, is to bring down. And so we bring down another 2. And then, guys, we just simply repeat. And we repeat as many times as we need to. So if we follow this cycle again, 5 divides into 22 4 times. The next step is to multiply. 4 times 5 is 20. The next step is to subtract. 22 minus 20 is 2. And then, of course, the next step is to bring down. So we bring down a 3, and we do it again. 5 goes into 23 again 4 times. 4 times 5 is 20. We subtract. We get 3. And we would bring down if we could. But if you go back to how you learned in elementary school, because we got a 3, that means it was a remainder of 3. So you've done this before, okay? And so just in case you weren't aware, like if you had really good math teachers back in elementary school, they would have taught you how to check your work. And so to check your work, you would have said 723 equals 5 times 144 plus your remainder plus 3. And so let me make sure you realize some stuff. This 723, that's called your dividend. Okay, it's what you're dividing into. So it's your dividend, you're going into it. The 5 right here is what you divided by. So it's called your divisor. Okay, 5's your divisor. 144, well, that was the answer to a division problem. And you remember from back in the day, the answer to a division problem is called a quotient. And then we all know that this little 3 over here is called the remainder. Why am I making this a big deal? Because you have to be able to understand this vocabulary in order to understand this section. Okay, because my math lab recognizes this. And so if you remember, another word is called a factor. So 5 is not a factor of 723 because it does not divide evenly. Like, why is it not a factor? Because we got a remainder of 3. Because we have a remainder of 3. The only time something is a factor is when you get a remainder of 0. So think about it. Like 4 is a factor of 20 because 4 divides evenly into 20. 8 is a factor of 16 because 8 divides evenly into 16. So 5 was not a factor because it did not divide evenly into 723. So now let's take this from numbers, just integers, and let's use polynomials. So I'm going to look at, actually I'm going to make up a problem on my own. The problems on the PowerPoint are pretty straightforward in my opinion, so I'm going to make up another problem. So example 1, determine if x plus 1 is a factor of x cubed plus 5x squared plus, 3x minus 4, okay? So let's take a look. If you remember what I just said, in order to be a factor, that means when you divide, you get a remainder of 0. So we are simply going to take x plus 1 and divide it into that long polynomial. So we've got x cubed plus 5x squared plus 3x minus 4. As weird as this sounds, we can do it, okay? And so if you remember that process, let me write it down again. It was divide, multiply. In elementary school, we call it subtract. In college algebra, I'm going to call it negate. I'll explain that in just a minute. Number 4, it was bring down. And then number 5, it was to repeat as many times as we need to. So let's get it. Okay, so we're going to divide. Let me put this in a box because this is super important. Okay, so we're going to divide x into x cubed, which is very, very confusing for kids. Okay, so over here, I'm just going to have a little bit of side work. So side work for those of you that need to see all the steps. So we're dividing x cubed by x, guys. And hopefully you recognize that x cubed divided by x is x squared. So I'm going to put x squared up here. Okay, so step 1, divide, done. We divided. Step 2, we're going to multiply. So x squared times x is x to the 3rd. But hold up, we also need to multiply x squared times 1. And x squared times 1 is 1x squared. Okay, so step 2, divide. Step 3, negate. So I'm going to come up here and change colors so it doesn't get confusing. If I negate means change sign. So this is a positive x cubed, so now it's a negative x cubed. This is a positive 1x squared, so now it is a negative 1x squared. And now, go back black. Okay, so now x cubed minus x cubed, well, that's going to cancel out. Okay, and 5x squared minus 1x squared is 4x squared. And let me give you a piece of advice. If this first term right here doesn't cancel out, then you have messed up somehow. Okay, so now after we negate, we are now going to bring down. So what do we bring down? We bring down plus 3x. And we repeat this process all over again. So how many times does x go into 4x squared? Well, people are like, I have no idea. So come over here in the side work. 4x squared divided by x. That makes way more sense. 4x squared divided by x we can see is 4x. So you're exactly right. I'm going to put a positive 4x at the top. And then I'm going to repeat again. 4x times x is 4x squared. And 4x times 1 is 4x. And you know exactly what to do. We're now going to negate. So this becomes a negative. And this also becomes a negative. And now we are going to 4x squared minus 4x squared. Look, it crosses out again. Nice job. 3x minus 4x is a negative 1x. Be careful with your signs. And then we're going to bring down again. Okay, so bring down a negative 4. And we do this all over again. So divide. Let me move up a little bit. Negative 1x divided by x. You can probably tell the x are going to cancel. It's just going to be negative 1. So we're going to put a minus 1 at the top. Minus 1 times x is negative 1x. Minus 1 times 1 is negative 1. And now we're going to negate. You should be getting the hang of this process. This is going to become a positive. This one is also going to become a positive. Okay. And take a look here. Negative 1x and positive 1x. Oh, it crosses out again, guys. And negative 4 plus 1 is a negative 3. Okay. So guess what that negative 3 is? Well, there's nothing else to bring down, which means that negative 3 is our remainder. That's our remainder of negative 3. And so the question asked, it says, determine if x plus 1 is a factor of that long polynomial. Well, no, x plus 1 is not a factor. X plus 1 is not a factor because, again, in order to be a factor, we have to have a remainder of 0. So x plus 1 is not a factor of x cubed plus 5x squared plus 3x minus 4 because there's a remainder which equals negative 3. So no, it's not. Okay. So now that was using that process that we just did, guys. That was called polynomial long division. And I don't recommend doing that process because it's a little bit more complicated than synthetic division. Okay. So I'm going to do that exact same problem. But now I'm going to do a part B with synthetic division. So let me write up here. This was long division. Okay. And so down here, down here, I'm going to do the exact same problem. So hold up. X cubed. There it is right there. So part B of the exact same example, x cubed plus 5x squared plus 3x minus 4. And I'm going to divide it by x plus 1. But now I'm going to use the process called synthetic division, okay? So let's take a look at this. So synthetic division is a shortcut for long division, okay? So you may or may not have ever seen this process in high school, but here it is again. So I'm going to draw this box right here. And this box is what you're dividing by. So you're dividing by x plus 1. But what I need you to remember to do is set x plus 1 equal to 0. So x equals negative 1, right? And so we're going to divide by negative 1. Okay, so over here I put a negative 1. Now, I list the coefficients out. I do not list the entire number or the entire polynomial. I only list the coefficients. So the coefficients that I see, the coefficient in front of that x cubed is a 1. The next coefficient is a 5. The next coefficient is a 3. And the next coefficient is a negative 4. Okay? So I'm going to bring down that 1. This is the same process every single time, guys. And then I'm going to now, once you cross that line and you're down here at the bottom, you're going to multiply back to your box. So 1 times negative 1 is negative 1. 5 and negative 1 make a 4. Okay, you cross the line, so multiply back to your box. 4 times negative 1 is negative 4. 3 minus 4 is a negative 1. Negative 1 times a negative 1 is a positive 1. And if you combine negative 3 and 1, you get a negative 3, okay? So you may say, what does this even mean? There's the answer, guys, and you actually have done the problem correctly, but now you need to convert this back to a polynomial, okay? So if you think about it, you were dividing x cubed by x. And like we discussed earlier, x cubed divided by x is simply x squared. So this 1 doesn't represent just a 1, it represents a 1x squared. And then the exponent decreases as we go. So that 4 represents a 4x. That is a minus 1. And that negative 3 is your remainder in negative 3. And so if you take a look back up here, the exact answer I got was x squared, right here, let me highlight it. X squared plus 4x minus 1 with a remainder of negative 3. X squared plus 4x minus 1 with a remainder of negative 3. Okay, this to me, part B, is way simpler than part A, but I need you to understand how to do the process of synthetic division. So if you read over the examples and then watch this example as well, you probably have synthetic division down pretty good. Okay, so again, it's not a factor because we did not get a remainder of 0. Okay, so that is an example of polynomial long division and polynomial synthetic division. And so the last thing I need to talk about is the remainder theorem. Okay, the remainder theorem. Now, time out. Most of your homework from section 4.3 is going to ask you to divide a polynomial like the one here with another term or another polynomial. Okay, so you're going to have to get good at either using polynomial long division or polynomial synthetic division. But if MyMathLab simply asks for the remainder, you can use the remainder theorem. Okay, so let me show you this. If MyMathLab only wants to know the remainder, so for the last example, the remainder was negative 3. If MyMathLab only wanted to know the remainder, the answer will be negative 3. So if I take a look at this and I have that exact same problem, x cubed plus 5x squared plus 3x minus 4, and I'm dividing it by x plus 1. Okay, the remainder theorem says if you set this thing equal to 0, just like we just did, so x plus 1 equals 0, we get x equals negative 1, and we plug in a negative 1 everywhere we see an x. So take a look. It'll be negative 1 cubed plus 5 times negative 1 squared, plus 3 times negative 1 minus 4. Look what happens, okay? Negative 1 cubed is a negative 1. Negative 1 squared is a positive 1 times 5 is 5. 3 times negative 1 is a negative 3. minus 4 more. Okay, well look here guys. Negative 1 plus 5 is 4. Minus 3 minus 4, okay? Hopefully you recognize then the 4s are going to cancel and your answer is going to be negative 3. So if you add all of these numbers, you get negative 3. Why is that important? Because if you take a look, let me get my highlighter back out, another color. The remainder to this problem is negative 3. And when we plug it in, we also got out a negative 3. So what's the shortcut? If MyMathLab only asks for the remainder, you simply take what you're dividing by, set it equal to 0, and then go back and plug it into the original, and that will give you the remainder, okay? So I want to show you one last thing before I get off of here today. If I ask you to divide x to the 4th plus 3x squared minus 2 divided by x minus 2, okay? So I'm dividing this polynomial by this polynomial. Okay. What I need you to recognize is that there is a missing piece over here. What do you mean, Miss Floyd? What's the missing piece? Well, let me show you. This is x to the 4th plus 3x squared. There are no x's, so there is a 0x minus 2. Please notice that this and this is exactly the same. This 0x that I included is called a placeholder, divided by x minus 2. And you may say, well, Ms. Flo, why did you not have placeholders in the first problem? Well, if you take a look back up here, guys, I didn't need a placeholder because I had a cube, a square, an x, and a constant. Here I had a quartic, a square, and look, I made a mistake. I need to go back and do it. Because if those of you that are watching this video right now, I'm kind of upset with myself because I made a mistake myself, but we need to go back and look. We're missing a cube. So let's fix it, okay? Let's fix our mistake. So we've got x to the 4th plus 0x cubed plus 3x squared plus 0x minus 2, okay? So I had to have 2 placeholders, okay? I was so stuck on getting a placeholder, I didn't even realize it. So we've got 2 placeholders. We've got a placeholder for the x cubed, and we've got a placeholder for the x, okay? And this is perfect. Divided by x minus 2. So let's use synthetic division and give you one more example. If I take x minus 2 and set it equal to 0, I get x equals a positive 2. So over here in my little box, I put a positive 2. I now list the coefficients. The first coefficient is 1. The second coefficient is 0. Next is 3. Next is 0. And last is negative 2. Okay. What's the first step? Drop the first number. And then once you cross that line, you multiply. 1 times 2 is 2. 0 and 2 combine to get 2. 2 times 2 is 4. 3 and 4 combine to get 7. 7 times 2 is 14. 0 and 14 combine to get 14. 14 times 2 is 28. A negative 2 and a 28 combine to get a 26. And so if you think about it, guys, you were taking an x to the 4th, right here, x to the 4th, and dividing by an x. So hopefully you recognize that's x to the 3rd. So this 1 represents x to the 3rd plus 2x squared. Remember I said the exponent goes down by 1 plus 7x plus 14. And your remainder is 26. And so if I ask you that same question I asked you at the beginning, is x minus 2 a factor of the polynomial? By golly, no, it's not, because we get a remainder.